Formative assessment on trigonometry. You're going to have right angles and non-right angled trigonometry on this quiz next week. Alright, so first question, you're given a couple of triangles here. One looks like a right angled triangle, the other is not a right angled triangle. ABD has a right angle in it. You're asked, first question, find the size of angle ABC. So start at A, go through B to C. That angle is here. We know part of the angle is 100. We need to find the rest of the angle here. I'll just call it B in triangle ABD. Label your sides. This is opposite the angle concerned. And then the hypotenuse is opposite the right angle. That's the longest side of that right angle triangle. Find a ratio that uses opposite and hypotenuse. That's the sine ratio. So the sine of B is going to be equal to opposite over hypotenuse. Okay, that's the lengths, 4 over 9. Now we're solving for the angle B. So you're going to use the inverse operation to find that. Okay, so the inverse sine of 4 over 9, what angle has a sine of 4 over 9? You go to your calculator. And we're asked to find the inverse sine of 4 over 9. Make sure I have my brackets in the right place. And it looks like my calculator is set for radians. Make sure that your calculator is set for degrees to get an answer that makes sense. Okay. Inverse sine of 4 over 9. And I get 26.4 degrees for that one. And you could write your full calculator display, that's not a problem. You won't get penalized for rounding that way. 26.4 degrees approximately. But that's not the size of ABC. Okay, that's only the little part of ABC. So we have to add that to 100 and you get 126.4 degrees for ABC. Okay. Next bit. Find the length of AC. Okay, so you're asked to find this length here. We're going to have to figure out what rule to use. Okay, this is going to be non-right angle trigonometry. This angle now is 126.4 degrees. And we know the lengths on either side of it, so it's actually going to be the cosine rule. I don't know anything across from any particular angle. So I'm not using the sine rule here, I'm going to use the cosine rule. So 126.4, 10, and 9. So the length is like Pythagoras, that the calculation we're going to do is the square root of the sums of the squares. Okay, so AC is going to equal to the square root of the sums of the adjacent sides of that angle at B. Okay, so we said that was 10 and 9. So the sum of the squares. Then we do a correction factor for the angle not being a right angle, and it's minus 2BC cosine the angle 126.4. Okay. So that'll give me the length because I'm going to take the square root of that entire quantity. square root 10 squared plus 9 squared minus 2 times 10 times 9. All right, finish up that problem on the finding the length of the opposite side. Use the cosine rule, square root of the sums of the squares minus the correction factor as shown. Put it in the TI-84 and I got a value of around 16.96. I'm going to round that up to 17 centimeters. And next problem. The diagram represents a triangle. You see that there's some right angles in the triangle, and we're asked to find, actually the first question is finding the angle ABC, which is this angle up here. You start at A, you go through B, and come down to C. Okay. We have two angles out of this triangle. Let's find the third angle up here, ABC. 180 minus the sum of the other two angles, 75 plus 55. That's 130. 180 minus 130, I got 50 degrees for ABC. Okay, that might come in handy later. B, find the length of AC. Find the length of AC. AC is this side here. We know 25, which is opposite of 55. So we're going to use the sine rule to answer this question. So again, let's make that x. X over sine 50 degrees is going to be equal to 25 over sine 55. Okay, so we should get something a little bit smaller than 25. Look at the calculator there. You're just going to do solve for x, move the sine 50 up. X is going to be equal to 25 times sine 50 divided by, notice that I put the brackets in there, got to put that in there, sine 55. $23.4. So x is 23.4. That's the length of the opposite side. And that's going to be meters. Find the area of ABC. That's the entire field, ABC. Looks to me like we're going to need a height somewhere. So you have the option of, we know two sides, but we don't know AB. So we could find AB using the sine rule, continue with the sine rule. Or we could try and use another height to find the area of the triangle. So I'm going to use another height. I'm going to use this height here. Okay, so that height, the right angle's down here, and we just found the base is 23.4. That height is going to be based on the hypotenuse 25. Okay, so you use the area formula. Area is just going to be AB sine C, although it's not C this time, it's another angle, times 1/2, of course. So 1/2, 25 times 23.4 times the sine of that angle up there that we're going to use. Actually, we're going to use 75. We're going to use 75 for our angle. Okay. Okay, put that into the calculator. 0.5 times 25 times 23.4 times the sine of 75. $282.5 square meters, or you could round it up if you wish. Okay, no specification on the accuracy of your answer. Calculate the length of NM. Okay. We're given a lot of information there about it being the midpoint of a side and everything. I'm going to use the sine rule again. Okay. This time, Cn, which is the entire length there, that this entire length is opposite a couple of angles here. So we have a couple of choices here. And actually, I'm going to use a right-angled trigonometry to find that. So this is the more accurate side. So this is the hypotenuse. This is opposite 50 degrees. So the length of this side over 25 is equal to the sine of 50. Okay, so Cn over sine of 50. So is Cn over 25, I said. Okay, so we find Cn, and we're going to divide that by 2 to find the length nm. So 25 times sine 50, and you have that opposite side. Okay, my calculator tells me that that is 19.15, if you wish. And then we're going to divide that by 2 because nm is Cn divided by 2. All right, so just divide that by 2. $9.6 approximately meters. Wow. All right, back to the goat problem. The goat is attached to a length of rope that's 7 meters long. The other end of the rope is attached to point M. Decide whether the goat can reach the midpoint of CB, which we're going to label P. All right, so the goat is attached to M. He's got a tether that's 7 meters long, so that's like a circle with a radius of 7. Okay, that the goat can reach, and then the midpoint of BC half of 25, 12.5. We're going to call that point P. Okay, my diagram is not to scale, so we're going to have to figure out how to find that distance from M to P. All right, well, it's a triangle. Okay, and we just found the side CM, which was half of NC, and we just found that was 12.5, and that's 9.6. I also need the angle MCP. So before I had found the angle up here was 50 degrees. So 90, 50, 140. So this angle down here must be 40 degrees MCP. Okay, so go down and use the cosine rule. Again, with those lengths and sides. So the distance is going to be the square root of that distance we just found before, 9.6 squared plus 12.5 squared minus 2 times their product, 9.6 times 12.5 times the cosine of the angle 40 degrees. Square root 9.6 squared eight 8.03. Well, the goat can't get there because that's greater than 7, the length of the tether. So no, the goat's not going to make it. Go to problem 3. All right, we have a quadrilateral here, A, B, C, D. And we're given some lengths. BC is 190. Okay, this last problem, Pauline buys a piece of land. She knows this length BC is 190. The length of CD is 120. The length of AD is 70. And we know a couple angles, BCD and BAD, the bad angle. All right, first problem, Pauline decides to sell a triangular portion of land, ABD. So she wants to sell the part at the bottom. Draw a line from B to D, straight fence. Calculate the length of the fence. Well, I can use the top triangle BCD and the cosine rule because I have side, angle, side. So BD is just going to be equal to the square root of the sums of the squares minus the correction factor for a non-right angle triangle. So I'll just take the square root of the sums of the squares, 120 squared plus 190 squared minus 2 times 120 times 190 times the cosine of that angle was 75 degrees. Put that in the calculator. You can see my previous calculation here. I got 196.7 or 197. You can round it up as you wish. And then the next question, asked how much is that fence going to cost, Pauline? At a cost of $17 US dollars per meter. So I just multiplied my answer times 17. I just did A times 17, my answer. And I got 3,300, excuse me, and 44 US dollars is what I got for the cost. All right, next question. Show the size of angle ABD is 18.8 degrees. So ABD, that's this angle here. Show that it's 18.8 degrees. Well, I know an opposite side here, and I just found this side here at 196.7. So I can use that data with the sine rule to find the size of the angle. So set up your equations. And again, I want to find ABD, which we think is 18.8. So that's the sine of ABD divided by its opposite side, which was 70, is equal to the other angle, 115 degrees, divided by 196.7. And then I'm going to solve that equation for ABD. So I'm going to end up using the inverse sine of 70 times the sine of 115 in the numerator, and then the denominator is again 196.7. Okay, put that in the calculator. Again, I'm going to use the second key to get the inverse sine, and then I'm just going to do 70 times sine 115. And I'm going to close the brackets here because I want to divide that product by 196.7. Close it again and find the angle. 18.8. Nice. Okay, so that's how I would show that the size is that angle. And now find the area of the angle, triangle ABD. Well, I know a lot of information now. I got 18.8 over here. I got the angle at the bottom, 115, and I know one or two sides. So I'm going to use those two sides in the area formula to find the area of the triangle, but I really need to know angle ADB to do that. Okay, so again, the total is 180 degrees in the triangle, minus 115 and 18.8. So that angle that I want, 180 minus 115 plus 18.8, that angle is 46.2 degrees. Okay, so I'm going to use that in the area formula. The adjacent sides are 70, 196.7, and sine of 46.2. And I got an area of about, let's see, uh, 4969 approximately square meters. She sells the land for 120 per square meter, so I just again multiply that area instead of length times the cost per square meter, And she's looking at upwards of $500,000 for her sale. Don't know what happened to Part E. We deleted that. All right. 596,000. I should have made that 5 at the end. All right, Pauline, good luck with that.